That circular reference warning is Excel's way of saying, I'm stuck. Your formula is trying to use its own result to calculate itself, and Excel can't decide what the value should be. Sometimes it's a simple mistake, like adding a total cell into the same total. Other times it's intentional, like building a running balance that updates through iteration. The problem is, the warning doesn't always tell you where the loop is, and if you ignore it, you can get silent wrong numbers that look perfectly reasonable. In the next few minutes, you'll learn a reliable process to locate the exact cells involved, understand the type of circular reference you have, and choose the right fix. We'll also cover when circular references are actually useful, and how to control them safely with iterative calculation. The goal is simple: no more mystery warnings, and no more spreadsheets that feel off, but you can't prove why. Next step. Let's define it clearly. A circular reference happens when a formula depends on itself, directly or indirectly. Direct is the obvious one. Cell B5 contains a formula that references B5. Indirect is more common. B5 depends on C5, and C5 depends on B5, so the loop is 2 steps long. You can also get longer loops across multiple cells, or even across worksheets. Excel expects formulas to flow one way, like inputs to outputs. A circular reference breaks that flow, because there is no first step. Excel then has 2 choices. By default, it stops and warns you, or if iterative calculation is enabled, it repeatedly recalculates the loop until it stabilizes or hits a limit. The key takeaway is this: the warning is not about bad formulas, it's about dependency order. Your job is to decide whether the loop is accidental or a modeling choice that needs iteration and guardrails. Next step. Before hunting the loop, do one quick safety step. Capture the current state, because circular references can change results as you edit. Save a copy, or at least note key totals you care about. Next, identify whether the workbook is already using iteration. If iteration is on, you might not get a loud warning, but you can still have unintended loops producing settled numbers. If iteration is off, Excel typically points to one cell, but that cell is not always the root cause. It's just where Excel noticed the loop. Also, watch for volatile functions and links, because they can make the sheet recalc frequently, which makes a circular issue feel random. Your mindset here is troubleshooting, not guessing. We're going to use Excel's built-in tracing tools and a repeatable checklist. That way you can fix the real cause, not just patch the symptom. Next step. Here's the fastest built-in way to jump to the problem. Excel keeps a list of circular references it has detected. You can navigate to each one and inspect the formula. The important detail is that Excel may only show one circular reference at a time, especially if there are multiple loops. So after you fix one, check the list again. When you land on the flagged cell, don't just look for a self-reference. Read the formula like a story. Ask, what cells does this depend on? Then check those cells for dependencies back to the original. If the formula is long, break it into parts mentally. Look for totals that include their own total range. Look for percentages calculated from a value that itself uses that percentage. And look for helper cells that were meant to be inputs, but accidentally became outputs. Next step. When the loop isn't obvious, tracing is your best friend. Use precedence to see what feeds into the current cell, then use dependence to see what the current cell feeds into. You're looking for a path that leads back to where you started. A practical approach is to pick the cell Excel flagged, trace precedence one step, then inspect each precedent formula for references back into the chain. If the model is large, focus on the nearest logic layer. Circular references often happen at boundaries, summary rows, subtotal blocks, and grand total sections. Another common boundary is a dashboard cell that tries to both display and compute. If you find a loop across sheets, write down the chain in plain language, like Sheet 1 total uses Sheet 2 adjustment, and Sheet 2 adjustment uses Sheet 1 total. Next step. Let's cover the most common accidental circular references, because you can spot them quickly. Number 1 is the sum range that includes the total cell. It happens when someone drags a sum down one row too far. Number 2 is a running total that references itself instead of the prior row. Number 3 is a percentage or tax calculation where the base includes the tax, but the tax is calculated from the base. That creates a loop unless you restructure the math. Number 4 is a plug cell used for both input and output, like a discount rate that is overwritten by a formula. And number 5 is a copied formula that kept a relative reference when it needed an absolute one, pulling in the wrong cell and closing the loop. Once you know these patterns, you'll catch most circular references in seconds. Next step. Now the fixes. The cleanest fix is to restore one-way flow. Inputs on one side, calculations on the other. For the sum includes itself issue, adjust the range so the total cell is outside the summed area. For running totals, reference the prior row explicitly and lock the start cell if needed. For tax or margin loops, solve the algebra so the formula doesn't need its own result. For example, if total includes tax, then tax can be expressed as total times a rate divided by 1 plus the rate. For plug cells, separate the input from the computed suggestion. Use 2 cells, one for user entry, one for calculated output. And for copy errors, fix the reference type, absolute, relative, or mixed, so the formula points where you intended. The theme is the same: break the loop by design, not by accident. Next step. Sometimes you can't easily rewrite the math, especially in models with feedback, like interest compounding with constraints, goal seeking, a reserve, or allocations that depend on totals. That's where iterative calculation comes in. Iteration means Excel will recalculate a circular loop repeatedly, using the previous result as the next input. If the logic is stable, the numbers converge to a consistent value. If it's unstable, the numbers can oscillate or drift. So iteration is powerful, but it's also a responsibility. Before enabling it, ask 2 questions. First, does the model have a natural equilibrium, like a balance that should settle? Second, do you have a way to validate the result, like a check total or a reasonableness test? If you can answer yes, iteration can be the right tool. Next step. If you choose iteration, control it with settings that match your model. The 2 key parameters are maximum iterations and maximum change. Maximum iterations is how many cycles Excel will try before stopping. Maximum change is the smallest difference between results that Excel will accept as close enough. A higher iteration count can improve accuracy, but it can also slow recalculation. A tighter maximum change gives more precision, but can also cause longer recalcs or failure to settle. Start with moderate values, then test. Change an input slightly and see if outputs respond smoothly. Also, document the iteration is enabled, because someone else might open the file and assume normal calculation rules. Finally, avoid stacking multiple independent circular loops unless you really need them. Debugging becomes much harder when several loops interact. Next step. Here's a safe pattern for using circular references without chaos. Isolate the loop. Put the iterative logic in a small, clearly labeled section and keep the rest of the workbook non-circular. Then add a sanity check cell that confirms the loop has converged, like the absolute difference between 2 successive values. If that difference is above your tolerance, flag it. Another good pattern is to include a manual on-off switch. For example, multiply the iterative adjustment by a control cell that is either 0 or 1. That lets you freeze results for auditing or turn iteration off to see the baseline. Also, avoid hiding iterative cells inside long nested formulas. Break the logic into helper cells so it can be traced. The easier it is to explain, the safer it is to maintain. Next step. Let's talk about auditing, because circular references are often discovered after numbers look wrong. Build quick checks that catch problems early. Use crossfoot checks where row totals equal column totals. Use balance checks where beginning plus change equals ending. Use ratio checks, like margins staying within a plausible range. If iteration is enabled, add a check that confirms the final change is below your maximum change setting. Also consider creating a dedicated checks area with simple pass-fail messages. This isn't about making the file fancy. It's about making errors loud. Circular references are dangerous mainly because they can be quiet. A few lightweight checks turn quiet errors into obvious ones, and that saves you hours of rework and awkward conversations later. Next step. What if you fix the obvious cell, but the warning keeps coming back? That usually means one of 3 things. First, there are multiple circular references, and Excel is only reporting them one at a time. Second, the loop is indirect and lives in a different part of the model than the flagged cell. Third, the circular reference is created by a formula that changes based on conditions, like if logic that sometimes points back into the chain. In that case, test the conditions. Try the inputs that trigger each branch and see when the loop appears. Also watch for references to entire columns, because they can pull in unexpected cells, including totals or helper rows. The fix is still the same process. Identify the chain, break it intentionally, then recheck the circular list until it's clean. Next step. One last mindset shift. Circular references are a design decision, not a surprise. If you don't want them, structure your workbook so calculation flows in one direction and keep inputs separate from outputs. If you do want them, isolate the loop, enable iteration with clear limits, and add checks that confirm convergence. Either way, you should be able to explain the dependency chain in one sentence. That's the real test of control. Now I'm curious about your use case. Do you prefer to eliminate circular references completely, or do you sometimes use iteration for financial models and allocations? Leave a comment with A for eliminate or B for use iteration. And if you want more Excel troubleshooting scripts like this, subscribe for future guides. Subscribe to keep optimizing your workflow and get back more of your time.